Hello, my name is Roxana Skurtu, and today I'm going to be showing you how to apply the circle theorems. This is just a short video to show you how we work, and I'm going to start now. It's a short revision. You're going to use this topic for GCSE, mainly in the higher level. So the arrow theorem says that if you have two angles like this, one of them based here in the center and the other one based on the circle, and they have, both of them, they have the same ending point, so they have the same chord here. Yeah, so this one here is a chord, and if they have the same chord, but one of them is based in the center and the other one is based on the circle, the one based in the center is going to be double the one on the circle. Yeah, so I have a few examples here. So if this one is 40 degrees, yeah, this one would be 20 degrees. Yep. In this case, we can say this is 100 degrees, and this one is 50. Yeah, so it's always half. And this one is 90, and this one is 45. Yeah, so this is the first theorem. Now, the second one looks like this. So, two angles that are both having the same starting point, the same ending point, and they are both on the circle, they are equal. Yeah? So, you have some examples here, this one and this one. If this is 35, this one is 35, yeah? Because they have the same chord, yeah, as I was telling you before. If they're the same chord, if they have the same chord, then they're both on the circle, they're equal. Yes, let's see. We have two others, so I'm going to take a different color, maybe a blue. So this angle here and this angle here, they have the same chord here. So they're going to be equal, yeah? So if this one was 45, this one would be 45 too. Yeah? In this case, we have this angle here and this angle here equal. And also this angle here with this angle here. Yeah? They have the same chords. And this one with this one, or this one with this one. Yeah? We're going to have some practice in a few minutes. So the next theorem would be the cyclic quadrilateral. It means the quadrilateral with on the circle, with all the endings on the circle, is always going to have the opposite ones are always going to be 180 if you add them together. Yeah, so angle A and angle C are going to be, yeah, angle A, this is how we write, plus angle C are going to be 180 together. Yeah, and as you can see here, it's 180 minus theta. Yeah, theta would be this one. So angle D is going to be 180 minus angle B, so which is the same thing. It means these two angles added together are going to give 180. Yeah, and then I have another a few other drawings. So this angle is going to be the same as this one. Yeah. And let's give them some values. I'm going to give them some values now so you can understand better. This angle here, let's see if this is 130. This one is going to be 50. Yeah, because 130 plus 50 equals 180. And then this angle here plus this one, if this one is 110, this one is going to be 70 degrees. Yeah, and the other ones, yeah, these two angles are going to be 180 added together. Okay, let's see, this was slide number 4. Slide number 5, angles in semicircle. Yeah, so as you can see, this is the center. Yeah, This is our center, and this is the diameter. This one is a radius, and it's equal to this side, which is a radius. Yeah, so if two angles start at the same point, yeah, they start in one side and then the other side of the diameter, they're gonna be 90 degrees, yeah, if they're based on the circle. Yeah, so this one is 90 degrees and this one. And we have another example here. Let's see, I think we have some lines. Okay, here's a line. So from here to here, yeah, so that one's gonna be 90 degrees. We have another one here, 90 degrees. We can have another one here, which is gonna be 100. It's gonna be 90 degrees, yeah. So all of these are 90 degrees, 90 degrees, and 90, yeah. Okay, now the second theorem on this page is the tangent theorem. Now the tangent theorem says that any tangent to a point is going to be perpendicular on the radius, yeah? So this is the radius here, and this is the tangent here, and they are forming a 90-degree angle, yeah? So I'm going to take another line, yeah? If we have another line here, that's another tangent, that's another radius. They are going to be perpendicular, yeah? So that's what it says. Here I'm going to give another example on this drawing here. This is a diameter, and this is tangent. And this is the 90-degree angle. Now I know it's a lot to process, but you're going to understand better when we're going to do some practice. Okay, alternate segments, yeah? Alternate segments. So as you can see, if there is a triangle and there is a tangent to this triangle, both angles going to this direction, yeah, both angles going this direction are going to be equal. Yes, I'm going to make another drawing for you. 1, 2, 3, and let's have the tangent here, yeah? So if the tangent is here, the angle going that way is going to be, yeah, that's going that way. And this same angle is going to be here, this one. And then this angle here is going to be the same with this angle here. Yeah, they're going to be equal. Okay? Now, the dual tangent theorem says that if you have two tangents and they meet in this point, here this side is equal to this side. And because you have a radius and a tangent, this angle is going to be 90 degrees, and this one. And also, as you can see, this is a quadrilateral, yeah? Which means this angle and this angle here are going to be 180 together. Okay. Yeah. And if you join this two, this line here is going to be equal to this line and to this line, yeah? So this triangle here, ACD, is going to be isosceles, and ACE is going to be isosceles too. Okay, let's make another drawing just so you can get it easier. Yeah, so any point that you choose outside of the circle, okay, if this is the center, these are the radiuses, right? So we have a radius here, perpendicular on the tangent, and the radius there. Okay, and let's draw another line. Here's the other line. So this side equals this side, and this side equals this side because they're both radiuses, yeah? And let's see. So these two triangles are equal. because they have two sides equal and the third one is common, and they have one angle equal. They both have right angles. Now, if you have, in general, if you have the measurements of the sides, you can apply Pythagoras in this triangle. Okay, let's move to number 7 now. Yes, this is the last one with a theory. Perpendicular from the center to a chord. So every time you have a line from the center to a chord, any chord is going to be perpendicular. That's what it means, yeah? So if we have another line here or another line here, and we draw, we put a radius. It's going to be perpendicular, yeah, to the chord, on the chord. 90 degrees and 90 degrees. Okay? And a triangle formed by two radii. So this is one radius, this is one radius, yeah? So a triangle formed by two, it's going to be isosceles, yeah? Because this side equals this side means this angle equals this angle, yeah? So it means it's isosceles. Okay. Now I'm going to show you a few examples and then I'm going to set some homework for you just in case. Now let's see, which one should we do first? Okay, so we have to find out angle D here, yeah? Okay, as you can see, this chord, yeah, there are two angles starting from here, ending here. There's this one which is 55 and there's this one which is also 55 because it starts from the same point, yes, and it has the same chord. So this is the same arc, sorry, not the same chord. The chord is a line. The arc is the round thing. It's a part of the circle. Yes, so a chord is a line. Sorry for confusing you. Okay, so if this is 55 and this is 87, we have 180 minus 87 minus 55. And yeah, and we take them away. So that first is going to be 93. And then we take 55 away from 93. That's going to be 38, yes. So this angle is 38 degrees. Yeah, so we used the theorem with, let's see how it was called. The arrow. Yeah, the arrow theorem. No, not that one. The bow. Yes, it's a bow, not a chord. Okay, let's go back. So the next one, we have an angle on the circle and an angle at the center. So this is going to be double. Yeah, it's going to be double the 52. So it's going to be 104. Okay, so we found out angle E. Now angle G is going to be 180 minus 104 because as you can see there's a quadrilateral here and these two angles are opposite. So altogether they're going to add up to 180. So it's going to be 76. Yeah, this one is 76 degrees. Now if this was 104, as we said before, this is an isosceles triangle because this is a radius and this is another radius. It means the angle F is going to be the same size as this angle. So it's going to be 180 minus 104, which is 76, but 76 are are both of them added up together. So we have to half them, which is 35 plus 3, 38. Yeah, so the angle F is going to be 38 degrees. So I hope you understood. Yeah, so first we looked at this angle and we realized it's going to be half of this angle here at the center, angle E. And then once we find out this, things are way easier because the opposite one is going to be 180 minus 104, yeah, minus angle E. And then in the triangle formed here, which is isosceles, we have two angles which are equal because it's isosceles. So we have 104, we take it away from 180, we get 76. So 76 are both angles added up together. So if we half them, it's 38. Okay, and the next one, let's see, the next one would be, we can find out this angle and this one, because as you can see, this is isosceles, yeah? So it's 180 minus 40 is going to be 140, and then we half it is going to be 70 degrees. So it means one of these angles, they're both of these angles, each one of them is 70 degrees. Okay, if this is 70 degrees, the opposite angle in this quadrilateral is 8, yeah, this one. So that's going to be 180 minus 70, which is 110. Yeah, because these two add up to 180. Okay? And slide number 9. Okay. Yeah, I'm going to explain it really fast. So as you can see, this point here and this point here, this angle starts, this angle is based on the circle and it has a diameter. Yeah, it starts at one point of diameter and it finishes at the other one. So this is going to be 90. So G is going to be the difference between 90 and 69. Yeah. In this case, it's the same theorem. This is 90 degrees. Once you realize that, you just have to find out this angle. Yeah, so the 58 and this one are going to be 90 degrees altogether. So you just do the difference. Yeah, in this case, this is equal to this because this each one of them is represents a radius. 43 is the same as 43 here. This is 90 degrees. Yeah, this is 90. So you take away, from 90 you take away 43, and that's how you find out K. Okay, and the last slide is with homework. Yeah, and then in the next session we normally check the homework that you had. We go over it and I explain if there are any questions, and you are free to come up with new topics or questions from homework. Thank you very much. Bye bye.